I think we should get going. Good morning, good afternoon, good evening, wherever you may be, and welcome to the 21st webinar in this discussion series on tipping elements, the notion of irreversibility and abrupt changes in the Earth system. My name is Laurie Laybourn. I am a visiting fellow at the Global Systems Institute at the University of Exeter, as well as an associate fellow at Chatham House, the International Affairs Research think tank. The goal of the discussion is to advance knowledge on tipping elements, to support efforts to increase consistency in treatment of tipping elements in the scientific community, to develop a research agenda, and to design joint experiments and ideas for the tipping point modeling intercomparison project, TIPMIP. And the network behind this series includes the Earth Commission, AIMS, or the Analysis, Integration and Modeling of the Earth System project, and both AIMS and the Earth Commission are hosted by Future Earth. Part of the network is also the Safe Landing Climate's Lighthouse activity of the World Climate Research Programme, the WCRP. And this event today is co-organised by the International Institute for Applied Systems Analysis, ISA, and the Potsdam Institute for Climate Impact Research, as well as the Global Systems Institute at the University of Exeter. I hope you all got that. So the focus for today is on the Global Tipping Points Report 2023. You can see there on our holding slide here. The report came out last week in the context of COP. What you're going to see today is a brief introduction of the report from me, and then we will go over to our wonderful section leads, so the people who led the sections on the report, who will give you a briefing on each of those given sections in turn. All of our speakers will present, and then at the end, we will have a Q&A session. But during their talks, feel free to pose questions in the Q&A function. You'll see that at the bottom of your Zoom screen, not the chat. Go for the Q&A one, and then make sure you indicate to whom your question is directed by using that feature. And then for those of you who see those questions coming through on the Q&A function, you can, of course, upvote those which you prefer. We will be encouraging our speakers to respond to some of those in the Q&A function using text. We will then get on to those questions. Some of the key questions I will bring up for us to discuss in the Q&A that we will have directly following the presentations. After today's event, we will post the recording and the slides that you will see on the Tipping Point Series Confetti webpage, the one that you will probably have used to have signed up to this event, so they will then be accessible into the future. So I'm going to kick us off by giving a brief introduction to the Global Tipping Points report, some of the key messages, but we will, of course, go into those in far more detail in some of the presentations that you will see coming up. The report is a huge endeavor, bringing in over 200 people from across the world. Some you're going to hear from now, some of you may be on the call. And this is the most comprehensive assessment of the state of tipping points, both those that are threats to us in the Earth system, as well as those that provide opportunities for rapid change within societies themselves. Our first key message is that the harmful tipping points, those within the natural world, pose some of the gravest threats ever faced by humanity, by our societies. Their triggering is no longer something that exists far into a hypothetical future, but something that is quickly coming upon us now. Their triggering would severely damage both the wider natural world and also threaten the stability of our societies. These are some of, if not the greatest threats that we face at the moment. And as you will learn, there are 5 major tipping systems that are already, right now, at risk of crossing tipping points at present levels of global warming. And the threat to the stability of our societies, we must remember, comes from the knock-on consequences of what these tipping points could do, as we will explore. It is not just the first order, the immediate impact of these abrupt changes in the natural world. It is how they cause cascading domino type effects as they destabilize societies. We do not have the governance at the global level that is capable, that is adequate in the face, in the scale of this threat, particularly for mitigation, adaptation, and loss and damage. And that is one of the key messages coming out of this report, that governance has got to be at the scale of the threat posed by these tipping points. It currently is not. Within that, one of the most powerful tools in our toolkit in responding to tipping points in the natural world is to harness similar dynamics within societies, what we call positive tipping points. They offer the prospect that, as you see here, coordinated strategic interventions can lead to disproportionately large and rapid benefits. We have seen how certain tipping points have seemingly been reached at times in recent years in triggering accelerated rollout of clean technologies and other beneficial changes in our economies, as well as in mindsets and politics, the rise of international justice movements reaching a wider audience. I think we could potentially see as an example of that. It is through our ability to trigger these positive tipping points that we can arm ourselves better to be able to deal with the threat posed by the negative Earth system tipping points, those destructive threats. One of the key things that we wanted to achieve with this report and with the huge amount of work that sits behind it is to improve not just knowledge production, but the engagement process between science and policy. This is something that I see through my role partly as a visiting fellow at the Global Systems Institute, but also with policymakers through my role at Chatham House. It is extremely important that those in governments and international organizations who have responsibility for assessing the greatest threats that societies face and the global community faces have internalized the implications of what Earth system tipping points mean. And there is a crucial role there for people within science who know the most about those tipping points to be working closely with policymakers to ensure that that assessment and management of these risks, and as well the management of the opportunities that come from positive tipping points and the implications for justice and equity, are properly then passed through the transmission mechanism between science and into policy and through that engagement process. This is a wonderful graphic that our amazing designers behind the report put together, which riffs off a number of the ways that the people behind the report think of this problem. We have these divergent paths. We are used to looking at bifurcating paths when it comes to the climate threat. That path is pretty clear when it comes to what tipping points mean for us. There is a downward path where a growing momentum of movement towards Earth system tipping points leads to their triggering, which then leads to more chaotic impacts in societies, more than we are already experiencing as a result of climate change and nature loss, which then could distract us from dealing with the root cause of tipping points, from decarbonizing, from slowing the global temperature rise, which leads to the trigger of more tipping points, more chaos, more distraction, less decarbonization, and then the potential to trigger more tipping points. That is that downward path that we must avoid. The upward path is where we are able to work collectively to trigger and manage and spread the benefits of positive tipping points and set off a more virtuous route where even if certain tipping points, destructive tipping points, are triggered, we're still able to maintain the momentum and trigger more and more positive tipping points to set off these virtuous cycles towards a plausible pathway beyond serious and worsening Earth system destabilization. We will hear more about elements on those different paths from the speakers in a moment. I'm going to finish off by quickly rehearsing some of our key recommendations that you will see in the report if you have a read. The first is what has been hugely on the agenda at COP, which is the phase out of fossil fuels and land use emissions. Now, the threat posed by tipping points, as we will hear shortly, really provides the latest, greatest, and in some ways most or more severe warning that we really need to get rid of fossil fuels, that they must be phased out, and that we need proper pathways to do so as we head towards the mid part of the century. The second is to strengthen adaptation and loss and damage governance. Again, tipping points add a particular impetus to that conversation. If, or unfortunately, when certain tipping points are triggered, it will require a huge amount of adaptation and loss and damage support to be able to handle those implications and to do so equitably. Tipping points should be included in the nationally determined contributions, the NDCs, and the global stocktake to ensure that the huge threat, as well as the opportunities from positive tipping points, are a key part of the international processes around the COPs. Fourth, policy efforts need to be coordinated to trigger positive tipping points. We see this already in some regards in the real economy. There needs to be a more concerted effort from governments and from partners across the private sector and across the world to actively identify and trigger these positive tipping points. And I'm sure we will hear more about what those particular candidates are for tipping points that could be triggered at the moment are. We think there needs to be a global summit on tipping points. There's a lot of summitry these days, but tipping points present this extraordinary threat, as well as, when it comes to positive tipping points, extraordinary opportunities. We need more of a global conversation on this, and the report recommends that the UN Secretary General convenes an urgent global summit that brings together not just governments, not just people from the private sector, but civil society as well, to have a discussion about the implications and what can and needs to be done. And then sixthly, we need to deepen that knowledge of tipping points and its translation into action. We know enough to warrant urgent action, but to calibrate that action under uncertainty, there is, of course, a need to deepen knowledge of tipping points and how best to work with policymakers to make that happen. I'm going to stop there. I hope that gave you a bit of an overview and a scene setter for the report. I'm going to stop sharing my slides so you can all see me. Hello, everyone. And now we're going to go to our wonderful section leads who will be able to talk to you in far more detail and far more articulately about what the report is saying. While that is going on, please don't forget to, at the bottom of your screen, use the Q&A function, not the chat function, the Q&A function, to pose questions to our wonderful speakers. So we're going to start off with David Armstrong McKay. David is a Research Impact Fellow at the University of Exeter and the Global Systems Institute. He's also working with the Earth Commission to set safe and just Earth system boundaries and is an associated researcher at the Stockholm Resilience Centre. Dave, the floor is yours.
Cool. Thanks for the introduction, Laurie. And yeah, hopefully you can see my screen. So I led this section along with Sina Laurie and these chapter leads, and we'll see lists of the authors as we go through. So yeah, to put a little bit of context into how we structure the report and where this section fits into it, we have 4 different sections. The first one that I led with Sina is on Earth system tipping points. This is kind of looking at the biophysical basis of what evidence there is for tipping points and tipping dynamics within the Earth system, going through each of the different parts of the Earth system in turn and looking at how they could interact and if there are early warnings of those. And then in section 2, which will we presented in a bit, we'll look at the impacts of those Earth system tipping points on society and people. Section 3 looks at the governance of that, how to prevent tipping points, how to deal with adaptation to tipping points. And section 4 is about the positive tipping points. So just a little bit of background first about what is the Earth system. So the Earth system is the interconnected complex systems at the surface of the planet that help sustain life. We normally divide these into different spheres. So we have the cryosphere. This is the ice-bound parts of the planet. Things like ice sheets, glaciers, permafrost, sea ice. In the biosphere, which is the global sum of all ecosystems, we split that into different biomes. So we have forests and the tropics, temperate and boreal zones. We have savannas and grasslands and drylands, kind of more open, drier landscapes. We have freshwater as well, going into the hydrosphere, all the world's water. The hydrosphere and atmosphere together they form the fluid parts of the Earth, so they're subject to circulation. So we have overturning circulations in the oceans. We have circulations and oscillations in the atmosphere as well. We have the jet stream here. We have the El Nino Southern Oscillation and clouds as well. And then underneath all that, the solid Earth, the lithosphere. And these all interact in a complex way that sets the global climate. We all know that the various different parts of the Earth system are under huge pressure now from human-driven changes. In particular, we know about climate change because of greenhouse gas emissions, but there are also things like habitat loss, pollution, which are particularly affecting the biosphere and also some of the circulation systems as well. Now, normally when we think about pressure or stress on a system, we tend to implicitly assume that there's a fairly linear, direct relationship between the pressure and the result, the impact. So you double the stress on the system, you double the impact, and so on. But what we know from studying complex systems is that sometimes you get non-linear changes. The amount of pressure at some point can lead to quite a different amount of change than you would normally expect. One type of non-linear change is tipping points. In this report, we define a tipping point as when change in some system that's being stressed, when that change starts to become self-sustaining once a critical threshold of stress or pressure is reached. And that leads to this sort of self-sustaining state shift about the system completely changes state from one to the other that's qualitatively different. And this is normally driven by positive or amplifying feedback loops, which we've illustrated here for an ice sheet. So on the bottom left here, we have a little feedback loop to do with how warming affects ice sheets. So global warming obviously leads to local warming over the ice sheet. This leads to greater surface melt and ice mass loss from the ice sheet. This tends to lead to the surface height of the ice sheet to fall as it loses mass. As we know, the higher up you go in the atmosphere, at least to a certain point, it gets colder. So as the ice sheet is getting lower down, it's falling in altitude, the surface is dropping into warmer air. That means that you're increasing the local surface temperature over the ice sheet, and that amplifies the surface melt that was being driven by global warming. So you can see how you can start to amplify the amount of melt you get by this feedback loop. Normally, this is fairly kind of a limited process. On the right-hand side here, we have a diagram of how this somehow amplifying feedback changes as the ice sheet height falls. On the left, you can see the orange arrow, which is the amplifying feedback. It's smaller than the initial red arrow, the global warming causing the initial fall in ice sheet height. So it's amplifying a bit, but it's kind of under control. But below a certain point, basically the ice sheet falls below a certain line where that amplifying feedback, that surface melt being driven by warmer air that it's dropped down into, that just becomes effectively out of control. It will keep on going even if you were to stop global warming, or even start to reverse global warming a bit. Even if you start to kind of pull things back, the ice sheet will start to melt down and collapse over long time scales. So you go from having an ice sheet to collapse, and that is the inevitable state shift you lock in. So also, I think there's something will happen on my screen in a moment, but I'll just skip it. I should have turned that off before starting. Never mind. Okay, so in this report, we scoured the scientific literature for evidence of tipping points and tipping dynamics across the Earth system. And our first key message for section 1 is that we have identified more than 25 parts of the Earth system that we think have evidence, clear evidence for tipping dynamics. That's based on looking at ancient climate records, looking at current observations, going through theory, and looking at computer models as well. This is our summary map, put all those different systems together on the same map. I'm not going to go through this map in detail because there's quite a lot on here. But the key takeaway is that you can see that these systems that have tipping points in cover pretty much everywhere on the Earth's surface. These are not things that you can think of as being far away, as being tucked away in an ice sheet somewhere that people don't live. They could affect all of the Earth's surface directly, and then the indirect impacts of those tipping points can also affect further away as well. What happens in the Greenland ice sheet does not stay in the Greenland ice sheet. So what I'll do now is I'll go through each of the different spheres in turn to give a bit more information. This is the chapter we have on tipping points in the cryosphere, which was led by Ricardo Winkelmann, Norman, and myself. with many authors you can see at the bottom as well. So as a little bit of a guide how to read this map, each of the different systems, which are presented as the coloured blob, has a label. In that label, there are a certain number of plus or minus signs and a red or blue colour. Where, for example, you see 3 plus signs and a red or the Greenland ice sheet, that's showing that we have high confidence it has a tipping point. Whereas, for, say, Arctic summer sea ice, the minus signs and the blue colour means that we have high confidence that there isn't a tipping point in that system. So based on this, we can see that there is decent confidence and evidence that there is large-scale tipping points in the Greenland ice sheet, West Antarctic ice sheet, and different parts of the Antarctic ice sheet as well. There's also reasonable evidence for there being local to regional scale tipping dynamics in permafrost on land and in mountain glaciers as well. Whereas, for example, Arctic sea ice, we don't think there is enough evidence to show that there's tipping dynamics in Arctic sea ice. And there's some question marks and uncertainty around whether Antarctic sea ice, for example, has tipping dynamics, and that needs further research. Moving now into the biosphere, the third chapter in our section, which is led by myself, Boris and Rota, and many other co-authors as well at the bottom. So here we have clear evidence that there are tipping points across various different biomes. These are all the different coloured blobs on this map, represent different types of biomes, for example, tropical rainforests, savannas, drylands, temperate and boreal forests, going into the ocean and coastal ecosystems as well. So you can see that there's evidence, for example, for degradation, tipping points in savanna, grasslands and drylands. There's the possibility of dieback at various different scales within the Amazon. The smaller the scale, the more likely we think it is, but it's still possible at a wider scale as well. There's evidence, for example, for coral reef die-off, that's already starting to occur. Mangrove and seagrass meadows as well are at risk of die-off, and various other ecosystems too. Moving into ocean and atmosphere circulations. You can see here in particular, we have ocean overturning circulations have medium confidence that they can have tipping points in them. In particular, looking at this purple blob snaking down the Atlantic here, this is the AMOC, the Atlantic Meridional Overturning Circulation that people talk about a lot. This is kind of the circulation that draws warm water northwards, and then it sinks in the North Atlantic, and this sort of helps overturn the global ocean, keeps it mixed over long timescales. That has the possibility to collapse. We split off this bit just to the left of it here at the top, the subpolar gyre. This is effectively a branch of the AMOC that can collapse sooner and separately to the wider AMOC. And also in this report, something that we highlight that as a new part of an assessment is that there's also a possibility of overturning collapse in the Southern Ocean as well. These are these pink blobs around the coast of Antarctica. So this is a similar process. Ice sheet melt can cause ocean mixing around Antarctica to shut down, basically. Moving more into the atmosphere, things are a bit more uncertain or unlikely. So in monsoons, we're uncertain about whether there's tipping dynamics in the South American monsoon or Indian summer monsoon. They're possible, we just don't have full evidence yet. There's a little bit more confidence in the West African monsoon, but again, that needs more research. And then things like the mid-latitude dynamics box here, this is effectively the jet stream, northern polar jet stream. That's probably not got tipping dynamics. And then things like El Nino Southern Oscillation, ENSO, and tropical clouds and circulation, we don't think those have tipping dynamics with medium confidence, but that could do with some more research as well. Oh yeah, and this chapter was led by Sina, with many of the co-authors at the bottom here as well. Next key messages are multiple drivers are destabilizing these systems, and some of these drivers could be quite close to tipping point already. This table is just to show you, I've grouped together the different key drivers together under climate change, habitat loss or shifts, pests and diseases, pollution or exploitation, and then each of the tipping points have been grouped on the left-hand side here. And you can see how that climate change really is a key one that cuts across all of the different tipping points, whether it's in the cryosphere, biosphere, or ocean atmosphere. And several of these have these warning arrows on them as well. We know that as we go beyond 1.5 degrees of warming, that makes it more likely that you could cause lock-in ice sheet collapse over many thousands of years. You get a lot more localized permafrost fall. Coral reef die-off becomes very likely across wide regions. and also the subpolar gyre I mentioned is at risk as well. We also know that for other systems, as you go further beyond 1.5 degrees, things like mangroves and seagrass die off, and possibly boreal forests as well, they start to become vulnerable too. But you can also see there are lots of other things apart from climate change that could be co-drivers that can make tipping sooner. So, for example, tropical rainforest dieback, obviously deforestation is a big issue there, and exploitation, degradation, harvesting of those systems. That actually makes it, for the Amazon, that's probably the bigger threat right now, is from deforestation. We also have things like pollution, so too many nutrients or air pollution. So nutrient pollution, for example, is bringing many lakes close to or beyond tipping points in many regions. And we know that they can affect other systems as well. So we also have looked at interactions and cascades. We know that most climate tipping systems tend to destabilize each other. This is based on the work in chapter 1.5 led by Nico and Anna. So in this map here, this has various different tipping system circles and also some other systems that interact with them that are not tipping per se, but have kind of nonlinear dynamics and connect them together. All these red arrows are destabilizing interactions between them. Blue is stabilizing. And you can just see that there's a lot more red destabilizing arrows between them than blue stabilizing ones. That indicates that when climate tipping systems interact, they tend to destabilize each other. That makes the risk of other ones tipping to increase. There's a chance, although it's highly uncertain, that this could potentially cause a tipping cascade where one system tipping causes another system to tip and so on. So one possible cascade here is if Greenland ice sheet up at the top here were to collapse, that releases a lot of fresh water into the Atlantic that could shut down, or weaken or shut down the AMOC here in the Atlantic Ocean. That then has knock-on impacts on tropical monsoons and the El Nino Southern Oscillation as well, which could affect, that sort of affects where rainfall bands are. That could affect the Amazon rainforest and cause dieback in parts of that. And it could even affect the West Antarctic ice sheet as well, because the AMOC brings warm water northwards. Collapsing the AMOC would mean that more warmth stays in the southern hemisphere. That means that there's more warming around Antarctica. So this is sort of somewhat uncertain at the moment, but we're already entering the realm of warming where some of these tipping points that could possibly trigger cascades are starting to be at risk. So this is something that definitely needs a lot more research and is a reason for caution. Finally, we will look at something called early warning signals that could possibly indicate a tipping system is losing resilience. So this is this idea that as a system approaches a tipping point, it starts to lose resilience, that's the ability to recover to its original state or to return to some sort of stable state. We illustrate this on the right-hand side here with these classic ball and valley diagrams. So we're assuming that the ball in this valley, in this blue one here, that's a system in its stable state. If you knock that ball around, it will tend to come back to the bottom of the valley, so it has some stability. And you can see that in these data plots are effectively showing this system. It wobbles around a little bit with noise, but it's basically stable. But as the valley loses stability, as we go from purple here over to red, that valley is getting shallower. It becomes easier for that ball to escape that valley. And because it's shallower, it tends to rattle around a lot more with the same level of noise. You start to see that in the red data here. You're getting longer and bigger oscillations, longer and bigger variability. And you can see how this starts to change the way the data looks when you do various statistics on it. And you can get this early warning signal of a particular statistical property of the data tending to increase. In this case, it's autocorrelation. There are various different early warning signals that we can look at. And in this map on the left-hand side here, this shows different candidate tipping systems where early warning signals have been looked for. Red shows where there's positive early warning signals, so a suggestion of destabilization. Blue is negative, so no sign of destabilization, and gray is uncertain. And you can see that in multiple different systems we've been talking about, there's some sign of destabilization. In particular, recent studies suggest that parts of the Greenland ice sheet, the AMOC or subpolar gyre, and parts of the Amazon rainforest are all losing resilience. And that's consistent with those systems moving towards tipping points. The trouble is that it doesn't tell us exactly when or even if they're definitely going to hit a tipping point. It just tells us they're getting unstable. And for this chapter led by Chris and Josh, this chapter has various discussions of those limitations and how we could potentially improve them. Just to finish up with section 1, some recommendations. Clearly, we want to prevent destabilization of these tipping systems, and that means urgent and ambitious elimination of greenhouse gas emissions through a fossil fuel phase out, reduction of other pressures like deforestation, black carbon emissions, and nutrient pollution as well, biosphere. We want to reduce all the uncertainties around this, improve our confidence through more research. That we have various key feedbacks and processes we want to focus in there and improve models around that. That will also help us to improve risk assessments around the potential for tipping cascades, which is an urgent question. And obviously, increasing our ability to pick up these early warning signals would be really great. We can do things like use machine learning, also invest in a lot more remote sensing for satellites and on-the-ground data, and looking into past ancient climate records as well, so that we can get better data and start to improve these early warnings. And that is it for section 1. Thank you.
Brilliant. Thank you very much, Dave. And there you have it, everyone. That's your briefing there on Earth system tipping points themselves. Please keep your questions coming in to the Q&A section at the bottom. Next, we're going to look at what the impacts of Earth system tipping points could be. We have Steve Lade to do that for us. Steve is an ARC Future Fellow at the Fenner School of Environment and Society at the Australian National University. And he's also an associate professor at the Stockholm Resilience Centre at Stockholm University. Steve, the floor is yours.
Thank you very much, Laurie and David. So I'm presenting on behalf of the co-leads of this section, Jesse, Jonathan, and Josh. Also like to thank the leads of each chapter, who you can see on the screen there, and also the contributions of all the chapter co-authors. And lastly, I'd like to acknowledge the traditional owners of the lands that I'm speaking to you from, the Ngunnawal and the Ngambri people, and pay my respects to their elders past and present. So where this section sits in the context of the report, we've just heard from David about Earth system tipping points. In this section, we look at the impacts of tipping points on people. The first substantive chapter, 2.2, looks at the impacts on people of those Earth system tipping points that David just talked about. But we then go further and talk about the possibility for negative social tipping points, cascades between those tipping points, and also early warning signals for tipping in impacts. We leave governance of these tipping points to section 3 and positive tipping points to section 4. So let's start with chapter 2.2. The logic here, as I mentioned, is that we're looking at the impacts of those Earth system tipping points on people. So for example, collapse of the AMOC could lead to regional climate shifts that have impacts on agriculture and food production, or ice sheet collapses could lead to rapid sea level rise and coastal flooding that lead to impacts on coastal infrastructures and migration. There has been, before this report, very little systematic assessment of the impacts of Earth system tipping points, especially quantitative assessments. An important reminder is that throughout this chapter, we're looking at impacts that are additional to those impacts that would occur without tipping. However, we do acknowledge that Earth system tipping points can accelerate climate change, the non-tipping climate change, and therefore also magnify impacts through that pathway. Chapter 2.2 looked at 5 Earth system tipping points: AMOC collapse, ice sheet collapse, Amazon dieback, permafrost thaw, and Arctic sea ice loss, and looked at the impacts of these Earth system tipping points on 6 sectors: water, food and energy security, health, biodiversity and ecosystem services, and communities and economies. Some of the findings that they obtained from the literature include that Amazon dieback could put 6 million people at risk of extreme heat stress and cause over $1 trillion in economic damages. Antarctic ice sheet instability leading to a potential sea level rise of 2 meters by 2100 would expose nearly 500 million people to annual coastal flooding events. I drew the link here between ice sheet collapse and communities and economies, but obviously there's impacts from that sea level rise across all these sectors. 70% of current infrastructure in permafrost regions is in areas with high potential for thaw by 2050. And an AMOC collapse would disrupt regional climates worldwide, substantially reducing vegetation and crop productivity across large areas of the world, with profound implications for food security. I've mentioned to you just a few of the possible links there. The chapter actually found evidence for all the possible connections in this diagram. All the Earth system tipping points that they looked at are likely to have some impacts across all these sectors. So we have a fully connected graph. What these authors of this chapter concluded is that Earth system tipping points have the potential for severe impacts on people and biodiversity. So far, when we've been talking about tipping points, we've only been talking about Earth system tipping points, but tipping points, as Laurie hinted at in his introduction, can occur in social systems as well. In chapter 2.3, we looked at negative social tipping points. Negative tipping points are those that are predominantly harmful for humans and the natural systems that we depend on. Important to remember is that here we're using negative in the value-based sense rather than any mathematical sense. These negative tipping points in society could be caused by the impacts of Earth system tipping that we mentioned just a couple of slides ago. They could also be caused more directly by non-tipping climate change. This chapter looked at 5 potential negative social tipping points. Going from right to left on the screen, the first cluster had 2 tipping points. The first was anomie, which is a breakdown of social norms, social ties, and a shared social reality, which results in social disorder and deteriorating mental health. Second negative social tipping point, radicalization and polarization, which we are already seeing around the world for other reasons. Next social tipping point, displacement, mass displacement of people and human settlements. Fourth negative social tipping point, conflict related to our political systems. And the last, and by no means the least, tipping points on that negative social side, financial crisis and financial destabilization. This is certainly not an exclusive list, but they were the 5 that were identified as significant for the following reasons. They could be triggered by Earth system tipping points or climate change. They have the potential to reinforce each other, as we'll explain in a couple of slides' time. They also have the potential to feed back on climate change and Earth system tipping and accelerate that biophysical change, leading then, of course, to another positive feedback between human and biophysical change. We see many examples of anomie around the world already today. For example, in Thailand, the 2011 flooding put victims at 50% higher risk of serious mental illness. In the United States, the 2018 Camp Fire in California led to increased chronic psychological issues in the aftermath, such as PTSD and depression. One conclusion of this chapter is that in the future, there is unlikely to be any such thing as business as usual. Business as usual is not a likely pathway in future. Either we manage to move to a positive future with positive tipping points, decarbonisation and sustainability, or we move along the negative tipping point trajectory, which are likely to reinforce each other and Earth system change and obstruct the chances of any positive tipping points. So as Laurie pointed out in the introduction, it is truly a bifurcation of pathways that we're looking at here. So as we just hinted at, these negative social tipping points can cascade, just like the Earth system tipping points that David talked about in section 1. These cascades can generate systemic risk, which is where the functioning of an entire system is compromised due to the interactions among its components. These cascades could be transmitted via the movements of many things, such as people, goods, capital, and information within and across boundaries. The scientific literature on cascades is, maybe unsurprisingly, is even more underdeveloped than the literature on the negative social tipping points themselves. This graph shows the result of a literature review that the authors of this chapter did. You can see that there's a substantial and growing literature on cascades of climate tipping points, as you can see in this reddish color in the top line. But for all the other clusters of papers that they observed, there were fewer than 10 papers per year, and in some cases, only 10 papers in the entire scientific literature on those cascades. So this means it's not really possible to make any general statements about cascades between negative social tipping points. Instead, the authors of this chapter took a case study approach. They looked at 5 examples of cascades and systemic risk in the Amazon, coral reefs, forced migration, Arab Spring, and Lake Chad. You can see here on the screen one of the diagrams that they drew for the Lake Chad case, which shows that there's a complex range of reinforcing feedbacks involving not just the biophysical shrinkage of Lake Chad itself, but positive feedbacks that move through aspects such as fishing, food insecurity, conflict, and competition. Finally, I'll talk about early warning signals. David talked about early warning signals for Earth system tipping points in section 1. However, we could also develop early warning signals for impacts and tipping in impacts directly. This plot, which comes from a paper shown at the bottom of the screen, was discussed in chapter 2.5. This study showed that in this particular case in northeast Kenya, an autocorrelation early warning signal could anticipate worsening of food security by 3 to 6 months. So 3 to 6 months before that worsening happened, they were able to observe an early warning signal. Just to explain this graph a little bit, the thick black line in the bottom panel shows the early warning signal. The horizontal red line shows the trigger threshold. You can see that the signal got above the threshold in maybe February 2016. The bottom panel shows the state of food security in that part of Kenya. You can see an indicator of food security in light grey at the top, which dropped a few months after that early warning signal passed its threshold. You can also see some other indicators of food security in blue, such as food price and soil moisture. There's a lot of work that needs to happen here to develop early warning signals for tipping in impacts, such as what data is available and what data is appropriate to use, testing these early warning signals, and then also integrating these early warning signals into decision-making systems. To conclude this section, the key messages regarding the current state of scientific knowledge are that Earth system tipping points have the potential for severe impacts on people and biodiversity. Negative social tipping points triggered by climate change and Earth system tipping points could have catastrophic impacts on human societies. Negative social tipping points could themselves cascade to create systemic risk, and early warning signals can be used to anticipate impact tipping points. Based on these findings, we recommend, first of all, that risk assessments and adaptation plans should give deeper consideration to implications of Earth system tipping points. We also recommend that research funders and knowledge institutions should invest in, importantly, interdisciplinary assessments of tipping point impacts, negative social tipping points, systemic risk, and early warning systems. And that's it for me. I'll stop sharing screen. Thank you very much.
Thank you very much, Steve. And we see there a lot of the knowledge behind why in the report there is the conclusion that the tipping points present some of the gravest threats societies have ever faced, partly because they interact with all other threats that those societies face. So next up, we're looking at the governance of Earth system tipping points. Manjana Milkoreit was the lead of that section. It's great to have Manjana here. She's a postdoctoral researcher at the Department of Sociology and Human Geography at the University of Oslo. And as I said, she led the governance related work for the Global Tipping Points report. Manjana, the floor is yours.
Thank you, Laurie, and good morning, everybody. It's great that you're all here. I'm presenting this work on behalf of a chapter team that consisted of about 20 or so brave social and natural scientists who've been tackling a topic that has not yet received lots of attention in the social sciences. So our chapter tries to answer the question, what can and should be done about Earth system tipping points? So what could governance of Earth system tipping points look like? The section consists of 4 chapters. In chapter 1, we deal with kind of general issues of governance with general principles and discussing which kind of actors and institutions should be engaged in this topic. Chapter 3.2 tackles prevention. How can we prevent tipping points? Then comes impact governance in chapter 3.3, and we address knowledge production and science policy interface in chapter 3.4. So I want to start with some key messages up front. This is a very scaled down version of what we discuss in the section, and I hope that many of you pick up the full report and dive into it. But here are some of the key messages. So governance efforts to address the specific and severe threats of Earth system tipping points that you just heard about from both Dave and Steve are currently lacking and urgently needed. So the governance institutions that we have a whole range of sustainability governance institutions, do not yet address these specific risks, but they should adopt responsibilities for this type of governance. And that would require significant adjustments and strengthening of these existing institutions. And I'll talk more about this, what this could look like in a second. We argue that this future governance framework for Earth system tipping points should prioritize efforts to prevent tipping events. So prevention has to be at the core of this, but also minimizing impact-related harms, fostering adaptation and resilience, and facilitating knowledge co-production. And these objectives can only be reached jointly through systemic changes that address the root causes of these changes with transformations towards sustainable and just societies. We do point out over and over throughout the section that in all domains of governance, the diversity of tipping processes need to be carefully considered. So we cannot just look at these as one category or types of change. That is kind of this one agenda item, but they are so diverse in their conditions of when they happen, what kinds of impacts they have, which scales and institutions should be dealing with them, that they really need attention each individually. So let's dive a bit into this first chapter, the introduction. The chapter deals with a broad range of general issues that we have to tackle whenever we start with a new set of challenges in the governance world. So we talk about what goals we should be pursuing regarding tipping points. So what are the most important objectives that we need to identify and prioritize in some way. Then actors, who should be involved in tipping point governance? So who has responsibility, but also who is affected, who has the relevant maybe skills and capacities, who should be providing resources. Then this is a matter of multiple scales. At what scale should tipping point governance take place? And how can we ensure cross-scale interactions? Which sites or institutions need to be involved? Which principles do we need to use to approach decision-making? So what should be the governance logics guiding this process? Who finances governance efforts? That is a big topic regardless of which domain we're tackling, who pays for these efforts, is always important. And then what's the role of science and knowledge and predictive capacity and tipping point governance? So all of these are addressed in this chapter, and I will obviously not dive into one, but I just want to point out that some of the key principles that we identified concern polycentric governance. So this is a multi-scale issue, both in terms of spatial and temporal scale. So this is polycentric governance. It has to be anticipatory. We have to significantly expand the temporal reach of our decision-making and identify different temporal horizons that we need to consider in our decision-making. It needs to be systemic risk governance using principles of precaution, equity, and justice. And the last one I put on here is what I call extreme intertemporality. And that concerns the issue that tipping points really highlight the fact that our near-term decisions that we collectively make in the world as an international community have potentially deep time implications. And that really changes or should change the logic and the frameworks we use for decision-making, because what happens within the next, let's say, decade or maybe 15 years really is of significance for future life on planet Earth, if you will. Some of these tipping processes just connect these short-term processes to hundreds or thousands of years of future change on the planet. So this is encouraging us to think differently about the choices and the implications in the short term. We're trying to illustrate these intertemporal implications of tipping points with this figure and that I'm throwing up here. So just to orient you, we're using 3 tipping systems or tipping elements: the coral reefs, Amazon rainforest dieback, and the Greenland ice sheet, to give a sense of the temporal horizons over which tipping processes can unfold. So it shows you a bit of the diversity of tipping points in terms of temporal scales and how these temporal scales might correspond to the kinds of time horizons we use for our decision-making today. So you see here these 3 tipping elements and the typical visual representation of how that happens: 2 stable states and the system moving across the threshold and these peaks between these 2 valleys. And here you see on the x-axis the temporal scales from years to decades to centuries and millennia. And you see that these different tipping elements happen over very different time horizons, with some of the tipping points being potentially very close, maybe even within the next decade, and some of those maybe being a little further away, and also that they're unfolding over very different time horizons. And that has huge implications for what can and should be done when. For example, it means that the window for prevention of some of the tipping points we're looking at is possibly very short, maybe closing as soon as the 2030s, while for others we might have more time, but then also each phase, of course, comes with different implications for what can be done when. So let me move to prevention, which is really where most of our, or many of our recommendations center on the issue of prevention. So prevention of Earth's tipping processes should become the core goal and logic of governance. As I said, a short window for preventive action is open now for all of these tipping processes, and will close at different points in time for each tipping element. And for some, especially for those who are likely to tip or more likely to tip once we're reaching 1.5 degrees of global warming, that window could close as early as the 2030s. Many of these tipping systems have multiple drivers, and global temperature increase is key among them for most of these tipping elements. And that has, of course, implications for prevention. Prevention means we have to address all of these multiple drivers, which often operate at different scales. So temperature obviously happens at a global scale or is operating at a global scale, but many of these other drivers could also be operating at regional or even national scales or be driven there. And so prevention has several components. Key is, of course, that we need to rapidly strengthen current mitigation efforts to minimize temperature increase, to limit peak temperature, and to limit the overshoot beyond the global temperature goal of 1.5 degrees Celsius. Also, we need to limit the length of this overshoot period. So we really have to start rethinking viable mitigation pathways, in addition to reconsidering what is a viable temperature goal for the planet. Increasing sustainable capacities for CO2 removal will be also increasingly important once we consider that we will be overshooting 1.5 degrees very soon, and bringing temperatures back down to 1.5 or even lower necessitates removal capacities. And so we need to think carefully about that, how to scale up capacities for CO2 removal, to also think really about other effects that carbon removal could have. But that is now a necessary part of a mitigation strategy. And as I said, since this is a multi-scale concern, we have to address non-climate drivers at regional and national scales, like deforestation or pollution or extractive activities. The report also has considered carefully that with the increasing risks of triggering tipping points, we will likely also have an increase in conversation about more risky approaches to governing these risks, including solar geoengineering. Our message of a careful and challenging conversation is that geoengineering approaches to prevention face very deep ethical, technical, and political uncertainties, and they should not be considered technically available to use safely and swiftly within the coming decades, which is really when we need to do mitigation and prevention. So we don't have the option of using these and should not be thinking about or relying on these. And to the extent that they do become, we do research these and they become available, these approaches could at most supplement and not replace mitigation efforts. So here I'm showing you just a little chunk of a very important table in our section on prevention that distinguishes clearly the primary drivers and secondary drivers to help decision makers tackle and target their actions towards these different drivers, and to help them what needs to happen at what scale of the global system. So again, warming drivers need to be tackled at the global scale, while other drivers will have to be addressed at regional and national scales. And this only shows you a part of this table, so I encourage you to dive into this and make use of this rich material within this chapter. Briefly on impacts, a lot more can be said. Since we're already facing tipping point risks today, and that these will grow increasingly when we pass 1.5 degrees Celsius above pre-industrial levels, we need to start thinking about impact governance now. So we might not actually succeed in preventing all of these tipping elements from passing tipping points. And so here's some of our key messages on impact governance. The impacts, as you heard from Steve, can differ significantly from the already well-studied impacts of climate change. And that matters for impact governance. So key differences can include greater magnitude and acceleration of change, novel types of impact sometimes, and novel distributions of vulnerability. Also, the irreversibility of change really changes the logic of what we're expecting. So not just seeing linear trend changes in a certain direction, but we're seeing reorganizations of entire systems, and that really can change what is happening for societies. So our existing governance frameworks need to be revisited, especially our institutions for adaptation, for migration, and for sustainable development in general, to account for these very specific threats. We think loss and damage might take on a much bigger role if and when we are passing some of these Earth system tipping points. And that is important. So this domain of governance needs to be strengthened and grow significantly. So the objective of impact governance, especially minimizing harm, reducing vulnerability, and building resilience, are best achieved with just transformations towards sustainability. Again, this chapter has another big, very valuable table inside of it that defines and distinguishes different kinds of possible impacts of Earth system tipping points that need to have governance responses. So this is a huge amount of work goes into identifying these different impact kinds, and I encourage you to have a look at this rich table as part of chapter 3.3 in our section. And so here's a bit of a visual depiction of what impact governance could look like for a single tipping element across the three different phases of a tipping process, if you will. So here, the pre-tipping phase, and each of these phases can, of course, have very different temporal scales. So each tipping point has a kind of a pre-tipping phase when we're anticipating this is going to happen. So anticipatory governance, where learning is key, monitoring and early warning is key, building resilience, reducing vulnerabilities, and so forth. And once we're passing a tipping point, this is really where all the work of impact governance really kicks into high gear, where adaptive governance has to be the mode of work, and where we have to address at that point the different kinds of harms created, the disasters, transformative adaptation, addressing loss and damages, and so forth. So this is really distinguishing different modes of impact governance across different phases of tipping processes. And finally, our chapter 3.4 on knowledge co-production and science policy interactions highlights how important it is to generate the knowledge to support decision-making in this domain. As Laurie pointed out at the very beginning, it's important to think about how best to communicate about tipping point threats, how to help decision makers understand these and respond to these, and what kinds of knowledge to produce. So we need to support effective governance of Earth's tipping processes with solutions-oriented, context-specific, actor-relevant, and anticipatory knowledge. And our existing knowledge institutions, in many cases, need to be adjusted, reformed to better support this kind of knowledge production. Currently, we have huge knowledge gaps in the social sciences and the humanities. So our section really had to draw on very little, or could only draw on very little social sciences in this area. And we are making a strong call for more social scientists to engage in this, to expand our understanding of impact-related decision-making, governance, policy, perceptions, all kinds of issue areas that need to be better understood. We know that there are big learning challenges specific to tipping points, complex systems, nonlinear change that could slow down or impede governance efforts. So we need to really step up our understanding of how to address those. And we need to build anticipatory knowledge and related capacities that are currently weak in many of our knowledge production and knowledge use institutions. So I think for the sake of time, I'm going to skip this and just come to our recommendations of this section, which is that now is the time for governance actors across many domains and many scales to engage in the governance of Earth's and tipping points. We need to step up mitigation efforts to minimize the risk of passing, triggering tipping points. So accelerate our time horizons to reach net zero and to phase out fossil fuels. Parties to the Paris Agreement should include Earth's and tipping points in future global stocktake processes, and every country should make an effort to include an assessment of their risk exposure to tipping points in their future NDCs. Parties to the Paris Agreement should also initiate an evaluation of the adequacy of our adaptation, loss and damage, and finance mechanisms in light of these tipping point risks. Countries with the geographic scope of specific Earth system tipping elements should consider the need for initiatives at that particular scale of tipping elements. So we're lacking governance capacity often at the scale of tipping elements. And international organizations, national governments, and science funders should foster international research collaboration related to these issues. And that's it from me. Thank you.
Thank you very much, Manjana. And now we come to our final presentation. And before we do so, a reminder to keep any questions coming in the Q&A section for Manjana, for all of our speakers so far, and pop them in during the next presentation. So please remember at the bottom of your Zoom screen to get any of those questions that you might have. So now, as you can see, we're looking at the positive tipping points in technology, economy, and society. We have two speakers who will be taking us through that, two of our section leads. So we've got Steve Smith, who is the Tipping Points Research Impact Fellow at the Global Systems Institute at the University of Exeter. He's also a visiting fellow at the Centre for the Understanding of Sustainable Prosperity, or CUSP, at the University of Surrey. Steve co-led the work on positive tipping points. We also have Caroline Sim, who is a research scholar at the International Institute for Applied Systems Analysis, IASA, where she leads a strategic initiative on just transitions to net zero carbon emissions for all, or just trans for all. She's also working with the Earth Commission and co-led the work here on positive tipping. So, Steve, Caro, the floor is yours.
Thank you very much, Laurie, and thank you everybody for staying with us this far. And finally, some good news. So, Positive Tipping Points was written by 63 authors, including the section leads Tom Powell, Caroline Zim, Emma Bailey, and myself, and the chapter leads here. And next slide, please, Caroline. So section 1, as you've heard, covered Earth system tipping points. Section 2 looked at the impacts on people, which could also trigger negative social tipping points. Section 3 covered governance options for avoiding or adapting to those risks. And this section investigates the opportunities for positive social tipping points, but we shorten this by cutting out the word social and just calling them positive tipping points. So chapter 4.2 sets out a conceptual framework for understanding and acting on positive tipping dynamics. 4.3 is a series of positive tipping point case studies in energy, transport and mobility and food systems. 4.4 looks at the different enabling interventions that can be used in any sector and which can themselves have tipping points. 4.5 introduces the idea of positive tipping cascades that can act like a domino effect to beneficially transform multiple systems. And lastly, 4.6 looks at risks, equity, and justice in the governance of positive tipping points. So Caroline Zim will talk about the case studies in 4.3 and the tipping cascades of 4.5 and our recommendations. And I'll briefly summarize the other chapters now. Next slide, please. So key messages. Some of the key messages are that with the right interventions, transformative and just positive tipping points can emerge. Changes in behaviors, values, and institutions are as important as changes in physical things like technologies. And when we design ways to intervene in social systems, the avoid, shift, improve framework is often very useful. Next slide, please. So the definition of a positive tipping point is much the same as the positive tipping point, much the same as the tipping point definition you've already heard, except of course that in this case, the change is desired, intentional, and predominantly beneficial. Next slide, please. But who exactly does it benefit? Positive tipping points aim for collective, intentional transformation towards global sustainability. But not all such transformations are universally seen as positive or beneficial. So who is being asked to change? Where will the change be felt? And by whom? These are important questions, and we devote the final chapter of our report to consider these issues of power, justice, and equity, particularly regarding marginalized voices. Next slide. So what binds this entire report together is the fact that any sufficiently complex system that has alternative stable states can have a tipping point. And that applies to human systems as well as Earth systems. Many of the same terms and concepts used to study Earth system tipping points in section 1 and negative social tipping points in section 2 also apply to positive tipping points in this section. And there are also important differences, of course, including that positive tipping points inhabit different domains. Next slide. So we categorize these domains into technological, economic, social behavioral, and political domains. Human systems interact within and between these domains and the Earth system in which they're all embedded. And the big point here is that if our primary aim is collective intentional transformation towards sustainability, then we need to simultaneously address all of these domains together in a systems thinking approach, which leads to more fundamental change and which helps us to remember that ultimately there are sustainable limits. Earth systems have certain capacities to provide our materials and to assimilate our waste, and these are governed by, ultimately, the laws of physics. These have to come first. Next slide, please. So the key to understanding the conceptual framework of positive tipping point dynamics is this balance of feedbacks before and after the tipping point. So before the tipping point, which is shown here as a dotted vertical line in the middle of the figure, before the tipping point, dampening feedbacks or negative feedbacks are dominant, and the self-reinforcing feedbacks that drive change are weaker, as shown in position F1. But after the tipping point, as shown in point F2, it's the self-reinforcing positive feedbacks, such as learning by doing, or economies of scale, or social contagion effects. These are the dominant feedbacks, and they accelerate change, ideally to a new system state that is compatible with a safe and just world, which is the circle in the top right, green colored. But other outcomes are also possible, including shallower, less sustainable outcomes and unintended consequences. To encourage the desired outcome, agents can strategically intervene to leverage change during the enabling phase before the tipping point, such as by making the desired technology or behavior the most affordable, attractive, convenient, accessible, or morally acceptable option. Next slide, please. So we place these enabling interventions into 5 categories, beginning with social behavioral interventions such as community and network building that can shift social norms and create social movements. Next slide. And then we have political systems. So these are interventions that recognize that changes in policy often require, firstly, a widespread recognition of the problem, and then the building of political coalitions that then become policy advocacy coalitions. Any significant or radical policy change that you can think of, whether it's the transformation to renewable energy or changes in fundamental human rights, it's always the result of a long political struggle. Change isn't just triggered, it has to be fought for. Next slide, please. And then we have financial interventions. Financial systems have a central role in influencing purchasing, public and private investment, and capital allocation decisions in the transition to a post-carbon economy. And they are influenced by a number of positive feedback mechanisms. Next slide. And to digitalization, which has a very important enabling role to transform society in many sectors, from teleworking to mobility as a service to smart homes. And it's important also to understand and try to neutralize the negative feedbacks that can hinder beneficial change. Next slide. And finally, we have early opportunity indicators, which could allow us to measure our progress by detecting signs of an approaching positive tipping point. And this uses quite similar methods to those used to detect early warning signals in Earth system tipping points. So the example given here essentially detects the change in people's preference for electric vehicles over internal combustion engine vehicles by recording the increase in the auto-lag correlation and the variance of people's online viewing habits. It's essentially doing the same as the early warning signals in detecting the change in resilience of the system. So thank you very much. Over to you, Caroline.
Thank you, Steve. I will now give you some examples of tipping systems where we identified potentials for tipping if the right interventions are undertaken, enabling conditions are created. And we did this by case studies in energy, mobility, and transport and food systems, as these are important systems in terms of the greenhouse gas emissions, because in the end, this is what we are after for positive tipping points. In the first, we want to reduce emissions. And before we look into this, I want to introduce you to this approach that Steve already mentioned, the avoid, shift, and improve logic that we use to structure these different potentials. As I said, we want to reduce greenhouse gas emissions as fast as possible. And this is basically the impact of our systems in which we operate. So energy, food, or transport, for example. But there's different ways of how I can go about this. Yeah, I can improve a polluting technology that I use, for example, increasing the efficiency of an engine. And a lot of work has covered this actually. But we add a broader perspective when we look at the whole system, because I can also think about shifting to a different kind of activity or technology. Let's say maybe moving to public transport or more active transport, such as biking or walking. But I can also try to avoid the activity altogether by designing systems differently. So in the case of urban mobility, this would be, for example, to have more dense or 15-minute cities so that the travel distance is reduced. And both avoiding and shifting reduces the overall system size and impact. And before, mostly people looked at improving technologies, but if we leverage the opportunities in avoiding and shifting first, the overall system that remains that we need to improve is actually smaller. So this accelerates the change if tipping actually occurs. This helps us, yeah? And the reason that there's more research on improving and technology options is that this is because of cost-related data that is available or quantifications. And this is also what we saw in the report, that it is more difficult to find examples for avoiding and shifting, because often these have to be standardized and they're more challenging as they're often place-specific. They're related to behaviors, social norms, and the overall system and available structures. But there is good news, because there are examples where we can already see tipping. Why does this not move? Okay, sorry. So if we now look into the detail into these systems, we can say that we already see positive tipping points in wind and solar power generation, as they have reached cost parity, and also in leading battery electric vehicle markets. You see again examples of technology. But the supply of technological solutions on its own is unlikely to be sufficient to meet the decarbonization target. It's also important that we trigger positive tipping points in the demand for energy, transport, and food, for example, by making public or active transport the cheapest, most convenient options, or also that we do spatial planning differently. Again, we have to leverage the potential of avoiding and shifting in addition to improving. We also need to accelerate change in the food systems because of the positive implications for natural ecosystems. But these tipping points we have not seen yet. So for example, moving to more sustainable diets, as Steve mentioned, through maybe contagion effect, would be very welcoming, but it has not happened yet. They would have to be actively enabled by different actors. In general, we can say that some systems are more likely to tip than others. Systems that have high capital costs, low replacement rates, that are lumpy in terms of technology, and then they have strong reinforcing feedbacks that keep the original system in place, are systems that are less likely to tip. Steve already mentioned the positive cascades that we looked into this. We already had the cascade system approach in the Earth system tipping points, and similar to the Earth system, we can also have cascades within human systems. So this means that a positive tipping point in a system or domain, for example, the energy system, actually leads to cascades either within the system, but also across the system. So from advances in the energy system, this can also benefit and lead to a domino effect, for example, in transport systems. So depending on how the socio-technological, socio-ecological, and socio-political systems are interlinked, we can have different kinds of cascades. And so this is good news, because one kind of tipping can actually lead to really accelerated change that will give us an opportunity to reduce emissions quickly. And different actors, not only public authorities or governments, but many different actors can play a role in triggering such cascades. If you look for an example in the socio-technological systems, this would be, for example, when one sector has a certain technology that is, and the costs are reduced for that technology, but this technology can also be used, or the output of that technology is relevant for another sector. So, for example, the electricity is a general purpose technology. And with renewable energy becoming cheaper and cheaper, and electricity generation thus becoming cheaper, there's a potential for economy-wide cascading consequences across the electricity sector, but also for mobility, as we see with electric vehicles, but also for new forms of using electricity, for example, through heat pumps in thermal comfort. And at the same time, through this push, if we have also advances in battery technologies, this can then also again help renewable energy storage becoming cheaper, and thus we have a cascade across the energy and transport system, making new options more attractive than previously. I also invite you to read in detail our recommendations, because they are basically for all the sub-chapters a long to-do list of what can be done to enable positive tipping points in these systems. We have tried to summarize them for the entire section to these three, where we put a big focus on a comprehensive and systematic and transdisciplinary program of research and development. We also call on decision makers to think more systematic about and in a more coordinated way to think about how to approach this, both looking at the supply and the demand side, and again looking at different options of avoiding, shifting, and improving of how we go about our lives. And this also it shows that if we also show in our report that if certain small group country coalitions identify individual areas where they have great leverage potentials, then they can come together with the system thinking approach and align their interventions, and this can lead to a large impact. For example, here in this case of green ammonia. I know that, I'm sorry if I'm rushing so much, but I know that the time is running. And I want to finish with a big thank you to the team at Exeter University who managed all of us and brought us across the finishing line. And thanks a lot, especially to all the chapter leads and the contributing authors who provided their expertise so that we had such diverse topics and examples, as you can see now here, what we tried to present to you across all the 4 sections. You can see that this is a really big collective effort of so many people, because the print here is very, very small. I had to fit everyone on one slide. And we're very grateful that all the authors volunteered to become part of this endeavor. And now I really think we have to move to the very short Q&A session at the end. And thanks a lot.
Thanks, Caro. Thanks, Steve. And there you have it, everyone. That is your review of what the report shows. I know some of you have been asking questions and getting answers in the Q&A. As is customary with a webinar, we have seconds left in which we can have a very short discussion. I'm actually going to seize my chair's privilege here and ask one question based on some of those that I've seen in the Q&A, which is that where do we stand now on the governance agenda that was talked about in the report? And if I may, Manjana, can I come to you for some thoughts on that? I know we have had some developments at COP28 when it comes to some of the things that we were calling for.
Yeah, so it was interesting. I was at COP last week for a few days. And if you have been following it too, you might have seen that the language of tipping points has actually entered the negotiations through the global stocktake process. So we had a technical assessment or a technical phase of the global stocktake, and through that, tipping points, the Earth system tipping points or negative tipping points, have entered this conversation, and they've been part of every iteration of the global stocktake text, and they are now in there in the sense that the international community recognizes the need to better understand tipping points or other maybe low likelihood and high impact events, although these, as we now said, are no longer low likelihood events. But that language is now there, and there's a recognition that more information will be needed So I think the report comes at a good time to signal we are in the process of providing more insight, and we're trying to now actively link that, of course, to governance. I think the report already points out many more ways to address tipping points, not just to foster more understanding and to do more science on them, which is clearly what we need, but what should be also our governance responses. So we already have recommendations that go way beyond what the current negotiation text or the global stocktake text is saying should happen with regard to tipping points. But I think it is a big step up. Also important is that the negotiations came out with a clear message that 1.5 is the more important global temperature goal that we should be aiming for, and phasing out fossil fuels and accelerating mitigation should clearly help us keep 1.5 alive, as the saying went. So our report will clearly argue that that is the right goal, if not even trying to aim for a lower ultimate global temperature goal, given that the risks of crossing tipping points exists already today. So it was good to get that signal in the global stocktake text that 1.5 should be the more important global temperature goal. But overall, we're in the very beginning of talking about governance that takes tipping point risks into account. So this is a baby step, but an important step, I think.
That's great to hear, Manjana. Thank you. And I just want to amplify something that you just said there, which is that from a policy perspective, the direction I come at this from, these have often been treated as low likelihood, high impact, as Manjana was saying, as we've heard from across the report. Low likelihood is not necessarily the right phrase we should be using. High uncertainty is definitely one that can be used from a scientific perspective. From a policy perspective, the consequences could be so disastrous here that when it comes to risk assessment, we've got to understand that likelihood is growing, and the consequences, regardless of the likelihood, are extremely severe. I'm going to stop us there. We are a couple of minutes to the hour when we promised we would be done. I want to say a huge thank you to our speakers today. Please, wherever you are, clap your hands together in front of your computer screen. Ignore what anyone else thinks of that. So thank you to all of you who presented today, to our wonderful section leads. I want to amplify what Kara said about all of those who took part in this report, particularly those that corralled us, that administered the huge and complex process to make this happen. The designers who made the report and the slides today look so good. So a huge thank you to everyone who was involved. You can get in touch with us by going to the Global Tipping Points website that I'm sure we can post in the chat now. I want to thank you to all of you who joined us today, whether it's in the morning, the afternoon, the night, or the middle of the night, for coming and listening to us today. This was the 21st webinar in the discussion series on tipping elements, the notion of reversibility and abrupt changes in the Earth system. There will be new events in 2024. They will be announced on the website soon, so please check back there. And thank you, and enjoy the rest of your day wherever you may be. And please engage with the work. Thank you very much, everyone. Goodbye.